Good morning. Once again, welcome you for the chemistry class. This is Uma Maheshwar, chemistry lecturer. In this class, we are going to study about haloarenes. The definition of haloarenes: halogen derivatives of aromatic compounds with benzene ring. That's about the benzene ring is an. Observe that one fluorine, benzene ring with fluorine, and benzene ring with chlorine, benzene ring with bromine, and benzene ring with iodine. Fluorobenzene, chlorobenzene, bromobenzene, iodobenzene. These are the halogen derivatives. These are called haloarenes. Now we come to that second point, classifications of haloarenes. How do we classify these haloarenes? Depending upon the number of halogen atoms. So here's a monohalogen derivatives. Observe that monohalogen derivatives, only one chlorine and one benzene ring. One chlorine is there. So that's a monohalogen compound. Instead of chlorine, you may take bromine, iodine, chlorine again. So again, second one is depending upon the number of the halogen atoms. If the two halogen atoms are attached to benzene ring, then they are called dihaloarenes. Dihaloarenes. Yes, in monohaloarenes, dihaloarenes, and trihaloarenes. Trihaloarenes, you can observe here 3x or the X is nothing but halogens. So X is at the different position of the benzene ring 1, 2, 3. So that's about the trihaloarenes. Trihaloarenes. Again, the position of the halogen atom may be different. In the position of that 1, 2, 6, 1, 2, 3, 4, and 1, 2, 3, 4, 6, you can observe that when the position is here 1, 2, 3. Again, in this one 1, 2, 3, 1, 3, 4, 5, 1, 3, 5. Again 1, 2, 4. Again, the same type we can change the position also. This is about the trihaloarenes. Then after the trihaloarenes, then we have to learn about the different types of that, the things about the aromatic halogen, monohalogen derivatives. You can go for that one, how they are going to be different here. Again, aromatic monohalogen derivatives: fluorobenzene, chlorobenzene, bromobenzene, iodobenzene. Same type, aromatic with polyhalogen, 2 or more than 2 halogen atoms. So observe here 1, 2 dichloro. The position of chlorine atom in benzene ring is clearly given here 1 and 2. This is benzene ring 1, 2, 3, 4, 5, 6. 1, 2 dichlorobenzene. Same type here it is 1, 3. The position is 1, 2, 1 is there again, and then 2, then 2 is empty, and then 3. 1, 3 dichlorobenzene. Same type here it is also. Position is 1, 2, 3, 4. 1, 4 dichlorobenzene. So this is about how that the 3. If the 3 halogen atoms are trihaloarenes, so benzene ring is there, and then 3 halogen atoms, 3 chlorine atoms. That is about depending upon the position 1, 2, 3. 1, 2, 3 trichlorobenzene. Same type here it is 1, 2, 3, 4. 1, 2, 4 trichlorobenzene. Again the another one is there. Again you could go for this one. Here is 1, 2, 3, 1, 3, 4, 5, 1, 3, 5. 135 trichlorobenzene. This is about how the different types of the haloarenes. Halogen atom is attached to the benzene ring. How do you go for that one? Then again the preparation is there. How do you go for the preparation of that? Preparation of haloarenes. Preparation of haloarenes. This is the preparation. So you could observe here we are taking benzene ring, benzene, and chlorine. So when benzene and chlorine is treated each other, then in presence of ferrous trichloride, it forms chlorobenzene and hydrochloric acid. This reaction is called electrophilic substitution reaction. So this is one method of preparation of haloarenes. Halogen derivatives of benzenes are called haloarenes. Again, similarly, one more example is that benzene ring with bromine. When benzene is treated with bromine in presence of ferrous tribromide, it forms bromobenzene and hydrogen bromide. Again, haloarenes from diazonium salts. You could observe the diazonium salts. Come to the diazonium salts. Azo compound is di compound. Benzene diazonium compound. This is a benzene diazonium compound. This reaction is called Sand-Meyer's reaction. This is the Sand-Meyer's reaction. How do we prepare that benzene diazonium salt or diazonium salts? Here is an about aniline is there. Benzene with a amine group, that's aniline. When aniline is treated with sodium nitrate in presence of temperature of 273 to 278 Kelvin and plus hydrohalides, it forms one salt, that's a substituted compound salt. That's what total compound is that benzene diazonium halide. If you take chlorine, benzene diazonium chlorine, benzene diazonium bromine. This is benzene diazonium salt. Again, that benzene diazonium salt is treated with Kyprus halide. It forms aryl halide or haloarene. Aryl halide or haloarene. So this is about the formation of the haloarenes from one of the methods by using benzene ring. So just you can go for that one, how the different types of the benzene compounds with the halogen. These are called haloarenes. After this one we go for this is a simple preparation. Then directly we go for the another one is the physical properties and chemical properties of haloarenes. So here is the physical and chemical properties of haloarenes. I could go for that one, how the physical properties and the chemical properties. Just I magnify the image. You can go for here's in physical properties and chemical properties of haloarenes. How that one, the physical properties and the chemical properties of haloarenes come. First comes under that the melting point and boiling point of haloarenes. Melting point and boiling point of haloarenes. How do that melting point and boiling point of haloarenes takes place? This is one of the important aspect in the haloarenes. So some of the properties, melting point and boiling point, and the same thing is that the melting point with the different types of the solids. Just I come to that one. Melting point and boiling point, it is same as those of haloalkanes of the same number of carbon atoms. If the haloalkanes have the same number of compounds of the benzene ring, then they show that the same properties, same as those of haloalkanes of the same number of carbon atoms. But one thing is that increases the size of halogen atom, increases with the size of halogen atom. Iodobenzene is greater than, iodobenzene melting point and boiling point is greater than the bromobenzene, and it is greater than chlorobenzene. Again, it's greater than fluorobenzene. So this is about the one of the point of that. Then second, one more point is that the boiling point of isomeric dihaloarenes are almost same. Isomeric dihaloarenes. This is one special property of isomer unit of the dihaloarenes. And melting point of the para isomers. In this one, para derivatives and meta derivatives and ortho derivatives, depending upon the position of 1, 2, 3, we are going to define ortho, para and meta, ortho, meta and para. So ortho, here para is greater than ortho and meta. Ortho and meta. So that's what the thing is. How do you go for that ortho? Ortho, it comes under 1, 2. Then you go for meta. Meta here is in the position is 3. And this is para. Ortho, chloro. Just you could observe here, chlorine atom is 2 here. Chlorine atoms are 2 here. And again, this compound is called 1,2-dichlorobenzene. The melting point and boiling point of 1,2-dichlorobenzene is greater than that. This is about the ortho. And then para and meta. Which is that para here? We go for that one. Ortho. This is ortho and meta. The para is this one. The para isomers are greater than ortho and meta. Here's the structure is there. And again we go for this one. 1,3-dichlorobenzene. This is meta-dichlorobenzene. This is ortho and meta. This is para. Para comes under 1, 2, 3, 4. 4. 1, 4 is, that's called as a para. So para derivatives are greater melting point and boiling point than the ortho and the meta derivatives. So this is about the one point about the regarding the melting point. I conclude the melting point and boiling point of haloarenes is same as those of haloalkanes of same number of carbon atoms, that's higher level. Again, increases with the size of the halogen atom. Then iodobenzene is greater than bromobenzene, chlorobenzene and fluorobenzene. The greater is the fluorobenzene is last, iodobenzene is more, greater than bromobenzene, chlorobenzene and then fluorobenzene. Again, boiling point of isomeric catahaloids are almost same. Again, we are getting the three derivatives, ortho, meta and para. Para derivatives have more boiling point than ortho and meta. So this is one thing, is that this is very important for the examination, and these 2 points. Then come to that one, the density. How the density goes. I already told you density is nothing but the number, the arrangement of atoms, and whether it is aryl halides are heavier than water. So we come to know that one, alkyl halides and water. Again, that aryl halides heavier than water. These are heavier than water. Those are lighter than the water. Alkyl halides are lighter than the water, but aryl halides are heavier than the water. What happens when we put aryl halides in water? They sink to the bottom of the container. If you put aryl halides in water, they sink to the bottom of the container. Correct or not? Aryl halides ಅನ್ನು ನೀರಿನಲ್ಲಿ ಹಾಕಿದ್ರೆ ಅದು ಕೆಳಗಡೆ ಬಿಡುತ್ತೆ, ಯಾಕೆ ಹೆವಿಯರ್. ಬಟ್ ಆಲ್ಕೈಲ್ ಹ್ಯಾಲೈಡ್ಸ್ ಹಾಕಿದ್ರೆ ಮೇಲ್ಗಡೆ ತೇಲ್ತದೆ, ಬಿಕಾಸ್ ಲೈಟರ್. ಸೊ ದಟ್ಸ್ another property. Solubility. Again, the solubility, it is same. All the aryl halides are insoluble in water but soluble in organic solvents. So these are about the another content of the physical properties of the haloarenes. So after this one, we are going to learn the another properties, that is chemical properties. Chemical properties of haloarenes. Okay, observe here. Chemical properties. Just I make it magnifying image, zooming it. As we learn about the chemical properties, there are 2 chemical properties are there. The haloarenes undergo nucleophilic substitution reaction and electrophilic substitution reactions. Again, we come to that one. What are the reasons for the nucleophilic substitution reactions? Here are the reasons are there. Why do haloarenes undergo nucleophilic substitution reaction? This is about the reason is there. The first one is the positive resonance effect of the halogen group, the first point, and the second one is hybridization of carbon atom, and the third one is the stability of intermediate compound. Then electronic repulsions. Due to that electronic repulsions, it forms that it undergo in nucleophilic substitution reactions. Just to remember, why do haloarenes undergo nucleophilic substitution reactions? The 4 points are there. Positive resonance effect of halogen atom, hybridization of carbon atom, stability of intermediate compound, and electromagnetic repulsions. Again, we come to that another one, electrophilic substitution reactions. Here it is ESR reactions. How do that ESR reactions go? This is by increasing the electron density on benzene ring to facilitate the attack of electrophile. Very clear. So how that one it is? Again, you go for that. It is increasing the electron density on the benzene ring to facilitate the attack of the electrophile. This is the reason for electrophilic substitution reactions. ಎರಡನ್ನು ಕೂಡ ನೋಡ್ಕೊಳ್ಳಿ, ಯಾವ್ದಾರು ಬೇಕಾದ್ರೆ ಕೇಳ್ಬೋದು. ಐ ಥಿಂಕ್ ಯು ಆರ್ ಫಾಲೋಯಿಂಗ್ ವೆರಿ ಕ್ಲಿಯರ್ಲಿ. ಒಂದು ಸರಿ ಓದೋಕ್ಕೆ ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂದರೆ ಇನ್ನೊಂದು ಸರಿ ಅದನ್ನು ಹಾಕ್ಕೊಂಡು ಇನ್ನೊಂದು ಸರಿ ಕೇಳಿ, ಇನ್ನೊಂದು ಸರಿ ಪಾಯಿಂಟ್ಸ್ ಮಾಡ್ಕೊಳ್ಳಿ, ದೆನ್ ಯು ವಿಲ್ ಗೆಟ್ ಇಟ್. ಹಿಯರ್ ಇಸ್ ಅನ್ ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ ದ electrophilic substitution reactions. First we go for nucleophilic substitution reactions. Here's the nucleophilic substitution reactions examples is here. Come to this one. Here is the nitro and then chlorine. Both atoms are there. This is about chlorine as well as this is the para nitrochlorobenzene. The position is there, as we already learned about para nitrochlorobenzene plus sodium hydroxide. In presence of 443 degree Kelvin, it forms phenol. That's about what? Nitrophenol. Para nitrophenol. It forms para nitro because we have taken para nitrochlorobenzene, so it forms para nitrophenol plus sodium chloride. This is the reaction example for what? Nucleophilic substitution reaction. Then we come to the another reaction is there. Here is another one. So ortho para dinitrochlorobenzene. So observe here, ortho and para dinitrochlorobenzene. Observe the compound here. Two nitrogen atoms, nitrogen dioxide, nitro atom, nitro groups, and one chlorine. The position is ortho and para. Ortho para dinitrochlorobenzene. Ortho para dinitrochlorobenzene. So ortho para dinitrochlorobenzene treated with sodium hydroxide, it forms again ortho para dinitrophenol. So here the same thing is there. Ortho para dinitrophenol above para nitrophenol. So these are the example, another example for this. So here once again we go for the another reaction is here about three nitro atoms, ortho, para and meta. This is about the 2,4,6 trinitrochlorobenzene. 2,4,6 trinitrochlorobenzene. When it is treated with aqueous NaOH, it forms 2,4,6 trinitrophenol. So these are the example for what? The nucleophilic substitution reactions. Just you go for that one. All the reactions as you go for this. Then after this, just we come to that the another content of that one. Electrophilic substitution reaction. How do you go for electrophilic substitution reactions? Here is an electrophilic substitution reaction. So electrophilic substitution reaction. So how do you come to that electrophilic substitution? Just assume it. Just to take the go through this definition how it is. Electrophilic substitution reactions. Here haloarenes undergo electrophilic substitution reaction. They form the mix, the product of ortho and para substitutive products. Again the general reaction we are taking here. So we are taken chlorobenzene plus which consists of that ESR electron nucleophile is there, and it forms an ortho substituted chlorobenzene and then para substituted chlorobenzene. Here is a different and then the particular examples are there. The different electrophilic substitution reactions. Different electrophilic substitutions, we have that the four electrophilic substitution. One is the chlorination, nitration, sulfonation, and Friedel-Crafts reaction, Friedel-Crafts acylation and Friedel-Crafts acylation and Friedel-Crafts methylation. So different ESR reactions. How do you go for different ESR reactions? Here it is chlorination, nitration, sulfonation, Friedel-Crafts methylation and Friedel-Crafts acylation. What is the product is going to be taken the chlorination? Addition of chlorine in presence of anhydrous ferrous chloride, and then the chlorine atom is in nucleophile. That product will come. Then again that what? Electrophile. The nitration. And that nitration we are taking nitric acid and sulfuric acid. And again electrophile is nitro group. Sulfonation. Sulfonation concentrated sulfuric acid. Again sulfide SO3 positive and that one. Friedel-Crafts methylation. We are taking methyl chloride and anhydrous aluminum chloride. For Friedel-Crafts acylation, acetyl chloride and so come to this one, Friedel-Crafts acylation and methylation. These are once again give the importance for these two. This is about the electrophilic substitution reaction. Just to go for that one, how do the electrophilic substitution reactions are. Then we go for the detailed reactions for the chlorination, nitration, sulfonation and Friedrich acylation. So here it is. Just to take over the one chlorination. So first compound we are taking total chlorobenzene. This is how the haloarenes, how do the haloarenes treated with different ESR reactions. So chlorination, chlorobenzene with chlorine, chlorobenzene with chlorine in presence of anhydrous aluminum chloride, it forms ortho and para derivatives. Ortho dichlorobenzene, para dichlorobenzene, ortho and para derivatives. Again the same thing will come. So as we learned in the last class, what are the substituted compounds will form? Ortho and para. Here we know that one. So ortho substituted product and the para substituted product. So the second one is nitration. Again once again we go for that one. Chlorobenzene with nitration. Chlorobenzene plus nitric acid plus sulfuric acid, it forms ortho nitrochlorobenzene and para nitrochlorobenzene plus water. Again the same type, chlorobenzene with for sulfonation reaction, it is treated with concentrated sulfuric acid, it forms HSO3 compound, ortho sulfochlorobenzene and para sulfochlorobenzene. Again same type, Friedel-Crafts methylation. For Friedel-Crafts methylation, again you have to take chlorobenzene, haloarene reacts with methyl chloride and anhydrous aluminum chloride, forms ortho methyl chlorobenzene, para methyl chlorobenzene and hydrochloric acid. Same type, acylation reactions. In haloarenes, these reactions are important. When chlorobenzene is treated with acetyl chloride and in presence of anhydrous aluminum chloride, it forms again aceto derivatives of the chlorobenzene, then the para derivatives of chlorobenzene. So this is about how do the different reactions of the ESR reactions. This is about the reactions of the ESR of the halogen derivatives. Just to go through that reactions, how do all the ESR reactions will come. I think you're following that. Again the last one, other reactions of haloarenes. Just other reactions of haloarenes. How do you go for other haloarenes and other reactions? Again we come to that Roots-Fittix reaction, and Fittix reactions. What happens again, that one Sand-Meyer reactions, Friedel-Crafts acylation and Friedel-Crafts methylation comes under the Friedel-Crafts on that haloarenes group. How do the different haloarenes having the different types of the reactions. Here is about the other reactions of haloarenes. You could go for that. So here is other reactions of haloarenes. Just to give an importance for the two names of the reactions, Roots-Fittix reaction and Fittix reactions. The two reactions are there. Just magnify the image. Roots-Fittix. What happens in the Roots-Fittix reactions? Again, the Roots-Fittix reaction is the reaction which comes under haloarenes, the first chapter. So again, that one Roots-Fittix reaction, and that second one is a Fittix reactions. When haloarenes are treated with haloalkanes, observe here, both we are taking haloarenes and haloalkanes are treated together in presence of sodium in triether, it forms alkyl arene. So the formation of alkyl arene is the product of Roots-Fittix reaction. When haloalkanes are treated with haloarenes in presence of sodium in dry ether, they form alkyl arene. That reaction is called Roots-Fittig reaction. Here's a general reaction is that we have taken that one haloarene and here's an haloalkane. Haloalkanes and haloarene. Haloalkanes and haloarene. This is haloalkane, not alkenes. Haloalkanes and haloarenes. As the haloalkanes and haloarenes, consider this one haloalkanes. And haloalkanes and haloarenes in presence of dry ether, it forms alkyl arene. So for the benzene ring, alkyl group is going to join. That's called alkyl arene. Here's an example is there. When chlorobenzene treated with sodium and methyl chloride. Yes, methyl chloride is an alkyl halide, then aryl halide. Alkyl halides are treated with aryl halides, or haloalkanes are treated with haloarenes. They form the compound substitutive group, that is solene is there plus sodium chloride. This is called alkyl arene. The formation of alkyl arene is the product of Roots-Fittig reaction. You clear about that one. In Roots-Fittig reaction, alkyl arene forms. Come to the Fittig reactions. What happens to the Fittig reactions? In Fittig reactions, two haloarenes. So two haloarenes react each other in presence of dry ether. They form diphenyl. Diphenyl is the product of Fittig reactions. So all the 12 naming reactions are very important. In each chapter we are getting 8 or 6 naming reactions. Totally 42 naming reactions are there. Among 12 are important for the examination. Definitely you will get easy for the naming reactions if you go through the continuous practice. Here is an example. Here we have taken that one, the two haloarene. Here is one haloarene and another haloarene in presence of sodium in dry ether. In dry ether it forms that's called diphenyl. You could take the example, instead of X you could take Br or Cl, it forms a diphenyl. So this is other reactions of the haloarenes. So it comes to the end of that, all the different properties of haloarenes. So today's class we learnt about what are haloarenes, the different examples for haloarenes, preparation of haloarenes, physical and chemical properties of haloarenes, and in the chemical properties, nucleophilic substitution reaction and electrophilic substitution reaction, electrophilic substitution reaction and elimination reactions, and ESR reactions. As we have studied about the two different compounds, so we are going to conclude it once again. I repeat, in haloarenes, in chemical properties, give the importance for two, NSR and ESR. But in haloalkanes, we should go for the different chemical properties. And naming reactions, in preparation, Schwarz reaction, Finkelstein reaction. Again, Sandmeyer reactions in haloarenes, and Roots reaction in haloalkanes, Roots-Fittig and Fittigs in haloarenes. So three things you should keep that. First one is the different naming reactions, Schwarz, Finkelstein and Roots, and these are comes under haloalkanes. Sandmeyer's Roots-Fittig reactions comes under the haloarenes. I think you are following. Just go through very keen interest. The keen interest, it will bring you to the good learning. Okay, I conclude. Again, once again, at the last, I convey the best wishes for the dear students. ಎಲ್ಲರೂ ಕೂಡ ಕರೆಕ್ಟಾಗಿ ಇದನ್ನು ಫಾಲೋ ಅಪ್ ಮಾಡಿ. Once again, thank you.